Xavier Lacherat, the CEO of BlueNav company, from South France, close to Bordeaux in Arcachon. So we produce hybrid solution to combine with the combustion engine. So then we get the best of the two worlds: the speed, the range with the combustion engine, and then the silence, no emission, the accuracy, the super intuitive control thanks to the electric solution. We're the only one to do a retractable solution that allowed in 10 seconds to switch from electric to combustion engine. Like you can see on this demo, I just hold 5 seconds the system, and then I move from the electric propulsion to the combustion engine with the retractability of the system. It goes back into the box, and then there is no drag, so no limitation, no more combustion consumption, fuel consumption. Okay, so then I can also go back down. Then we will see some of the other demo later. It goes down in a bit less than 10 seconds. We have a product range in terms of hardware from 15 kilowatts to with the 11 kilowatts we just unveiled during the boot. It's based with an motor that has been designed and produced in France, and then the 8 kilo. So all this in a twin configuration will allow to make hybrids boats from 2 tons to 18 tons. We also have the configuration with a single motor. You don't have to be in the axis of the boat. It can be on the side, and then the turbine, like you see, as it rotates. So it's an azimuthal propulsion. Will trim to go straight, even if it's on the side of the boat. So this will be the on-tree solution. And then we will provide, and we're also the only one to produce electric motor and then to have software solution that empower the electric motor, which we call the smart navigation features. So the biggest, the main one is the virtual anchor, with trademark, and we also have a patent on it. So this virtual anchor allow, when you drive, just by pushing a button to activate the virtual anchor, and then we take the GPS point. The boat will learn the drift coming from the wind, and face this drift force to keep the position very accurately. So here you see that we're at 0 meters from the GPS point, just keeping the position. And the consumption for that is super small. It's about 100-300 watts per motor only, which means that even with a small battery pack, you will have several hours, more than 10 hours for this virtual anchoring feature. When you drive at low speeds, you suffer from the waves, the wind, the drift, and then you have to drive all the time. So just to remove the virtual anchor, you push the joystick, and so you have to continuously drive and compensate your heading. So what we also develop is a heading holder. So then the system will just go straight automatically. And if there is some lateral wind that push you, so you still continue to have the same heading, but you will drift, then there is the no drift function that will make the boat go that way, and then you're sure you go straight, which is the course follow feature. We're integrated with most of the MFD. So this is a Simrad on this demo, but it could be a Garmin, it could be a Navico, whatever. Then we connect to the cartography system in this MFD solution. So you put your path, and then you push just the go-to function. There is no point of interest in the system, but when you push the go-to function, then the boat will automatically drive and follow the point of interest in the cartography system. This is what we call the waypoint tracking. The integration is pretty simple. You put the motor on the transom, and then the power unit, the battery pack, and the communication control unit, or the additional material that will manage the motor. Then it's a separate system from the combustion engine, will ensure the security, and then you can go back home in electric in case of thermal engine issue. which are 2/3 of the intervention from the SNSM in France, so the rescue team. So 2 times out of 3, it's because of a combustion engine failure. So safety is pretty important in the nautic industry. The main customer we will address are basically for the diving activities or the sport fishing activities or the cruising or tourist charter activities where they will value the low speed, the silent, and the virtual anchoring. We are fully aligned with the United Nations 30-30 plan, which require to protect 30% of the ocean by 2030, and this is by the Marine Protected Area regulation. And when an area is under protection, either the thermal engine are forbidden or the anchoring is forbidden to protect the seabed. So the virtual anchor and the hybrid system allow to continue to have this social, economic use of this protected area without disturbing this plan. That's exactly what we're aim to. So technology for the customer experience to protect the environment. These are the 3 pillars that drives all BlueNav's work and innovation. Last year at the Met, we introduced a software application that extends and integrates the BlueNav solution. And for example, I drive the boat and I come close to a floating anchor. I am alone in the boat and there is some wind, so I will activate the virtual anchor system. So then I can quit the cockpit of the boat and then take my smartphone. I see the virtual anchor is activated, and being in the front of the boat, I can see that I need to move 1 meter on the left to be able to hook the boat. So then I will just move and say, oh, that will be the direction I want. I need 1 meter dot 3 to move on that, and then I just need to hold, and until I hold, the virtual anchor will move in the direction and for the distance. I was a bit too long, so I just have to release it, and then the boat stop and keep the position. So now I'm closer to the floating anchor, so I can hook it in safety. So this is one way to use the smartphone app to extend, in fact, the ability to drive the BlueNav solution remotely. This is a Bluetooth low energy connection. We unveiled during this event the 11 kilo, and the very specificity of this 11 propulsion motor is the fact that we have done it in the size and the footprint of the 8. Most of the solution, when they increase the power, will increase also the diameter of the propeller, and so the 11 in the competition will be based on the size of the 15. So the innovation we have done is to design a motor that has the thrust of a 11 kilo with the size of the 8. So this is to ease the integration capability on the boat. So then we maximize the integration capability and the thrust of the solution